Okay, now inside of our lift assembly, with this exercise, we're going to create the subassembly adjust rod, which will connect our claw with our pivot part. To do so, we'll start by selecting a template file, and for this instance, we'll select the standard millimeter assembly template file. And then we're going to save this as adjust rod. And then once it's saved, we can place our rod ends, and I want two instances of this rod end in our subassembly. The first one will be constrained automatically to the origin of our assembly, and it'll be the grounded base part, as you can see right here inside of our browser. Once I place a second instance, you'll see the second instance is also displayed in the browser, but is not grounded. So the second instance can be freely constrained, but the first one is actually grounded and cannot be moved. Now I want to place my link rod that I created from the previous exercise, and then I can constrain these three components together. Before you constrain components, you can rotate them to easily see the features you need in order to constrain them. I'm going to go ahead and constrain using the insert constraint my circular reference on my rod end to my link rod. And then the same, so let's rotate this around, between my first rod end and my link rod right there. Hit apply. I'm going to select apply because I want my constraint tool to still be open because I have more constraints to apply. I want to clean up my angles between my two rod ends to be in the same angle. So I'm going to click my angle constraint and then select a flat surface there to this flat surface on my other rod end and leave it at a 0-degree angle. Next, I want to fully constrain my rod ends to my link rod part file. And because there's not a circular or a flat reference to my link rod, I'm going to select with an angle constraint my rod end, and then I'm going to expand out my link rod and select one of my work planes located inside of the origin folder. Therefore, that flat face is now constrained at a 0-degree angle to the YZ origin plane of the link rod. This subassembly is now fully constrained and can now be inserted into my link assembly. So let's save it, and then go to our link assembly, our lift assembly, and we're going to place it inside, right there. Now with this placed inside my assembly, I can now constrain it. So first off, I'm going to use an insert constraint between my rod end and my claw, and I'm going to cancel out of my constraint tool because I need to show this. If I bring my adjust rod assembly up, you can see that it's not long enough to get to my pivot part. I need to mark this subassembly and the part within it, which would be my link rod, as adaptive, because I want the length of this subassembly to adapt so that these two holes can constrain together. To do so, I'm going to double click my adjust rod subassembly and then double click the link rod. This activates the part file inside my assembly file for modifications. As you can see, everything in my assembly file is grayed out and transparent in my browser, and also here you can see the features now within your link rod. The extrusion that I want in my link rod to be adaptive is this length, which would be extrusion 1. So I'm going to right click on this and make it adaptive. Doing so also makes my link rod subassembly or my part file adaptive, as you can see right here. But I need now to make my adjust rod adaptive. So just right click on your subassembly and just turn on the adaptivity. So if I switch over to my modeling view, you can see that the subassembly is adaptive. The part within it that will be adaptive is my link rod, and then the feature inside that link rod that is adaptive will be the extrusion. All three must be set to adaptive in order for me to clean up this distance. So with all those adaptive, I am now free to constrain, and I'm going to use just my axis make constraint between my link rod end and my pivot point. As you can see, the length of my link rod part file got changed to adapt to this distance. Now this assembly is fully constrained, but I want to show some movement between all of my components. Right now I cannot do this because my slide assembly here, or my sleeve, is fully constrained. I can make this more flexible by suppressing certain constraints to show movement. So let's do this by expanding the sleeve subassembly, and I'm going to make sure that I'm in my assembly view so I can see my constraints within my sleeve. So with this instance, I need to select Flush 2, right click on this, and suppress it, which will temporarily turn that constraint off. I need to do the same within my claw part file, and the angle 3 constraint, I'm going to suppress this. Now with those two constraints suppressed, I can now move my sleeve and show movement between all of my components.